And it looks like some of your pages are a little faded, so make sure you fill in where we have it. So we're solving quadratic equations, number systems, radicals, and rational exponents. So it's just entering in a little different number system. All right, so as you were growing up in kindergarten, you probably talked about the natural numbers, maybe even had the whole numbers, which the whole numbers are all the natural numbers, and then 0. So the whole number system is so much bigger than the natural number system. Has one more number. The integers start dealing with negatives and positives and whole numbers. Rationals are fractions or terminating decimals, or decimals that repeat. And if you have a terminating decimal or a decimal that repeats, there's a fraction that goes to it. And then you go into something called an irrational number. And an irrational number, on your calculator, if you plugged in square root 2 or square root 72 or pi or square root 8/23 on your calculator, it would give you a decimal as wide as the screen is. It doesn't mean it terminates at there. It's just your calculator has to know to truncate it after a certain region. Okay, so irrational numbers cannot be written as a fraction. Like you can't get rid of a square root sign and then make that a number. Okay, yes, you can take the square root of 4, which is 2. You make 2 a fraction, saying it's 2 over 1. That's not an irrational number. So an irrational number is a decimal that doesn't repeat and doesn't have a pattern to it. It just keeps going and going. Okay? All right. So it looks like on yours, you might not be able to see it. So realize that says 4 raised to the 1/2 power. And I'm going to show you how I will do this on the calculator. On my calculator, let me get out of this screen. So if I typed on my calculator, I went 4 to the 1/2 power. Depending upon which operating system, I might be able to go 1 divided by 2, and that looks like it's going to work. Sometimes on your calculator, again, depending upon the operating system, you want to put your exponent in parentheses in order to make it work. Okay, 4 to the 1/2 power is the same thing as the square root of 2 or square root of 4, which the answer comes out to be 2. Okay, so it's pretty simple to plug into a calculator. Your phones, when you have them, you realize that if it's vertical and you go to the calculator, if you turn the calculator sideways, by turning it sideways is going to allow you to plug information in and get these answers out. Let's go back here. So 4 to the 1/2 power is equal to 2. So 16 to the 1/2 power is the same thing as square root of 16, which is, what's the square root of 16? 4. What's the square root of 36? 6. So the square root, so if I had the square root of x, that's the same thing as saying x raised to the 1/2 power. Okay, they mean the exact same thing. Where the 2 comes from is technically on a radical sign. There's a little 2 that usually fits in that little check mark part. So in this part right here, we have a 2, and that's where the 1/2 power comes out. Okay, the 1 comes from because that's x to the first power if you have a number to the first power. So perfect squares: 0 times 0, 0, 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, 12 times 12, 13 times 13, 14 times 14, 15 times 15. Ideally, it would be wonderful if you had an understanding of the first 16 perfect squares. You're like, 16? Yeah, because it started with 0. Okay? So that's just a perfect square is a number times itself. That works. Okay? So what does the 1/2 power mean? 1/2 power means it's a square root. Okay? So this is the way you write it a different way. Perfect squares, again, you're just taking a number times itself. You do that, you get a perfect square. All right. We good so far? May I move on? Good to go. Then we get to x to the 1/3 power. So this is the same thing as saying this. The third root of 8 to the first, which is the same thing as the third root of 8. So do you think there is a number, an identical number that I can multiply by itself, total of 3 times? So 2. Yeah, so 2 times 2 times 2 is 8. So the third root of 8 is equal to just 2. If you looked at 27, the third root of 27, what do you think? 3. Anyone want to take a shot at the third root of 64? Go with the pattern, stay with the 4. 4 times 4 times 4. Okay, so this is the same thing as 4 times 4, which is 16. 16 times 4, which is 64. Okay, perfect cube. 0 times 0 times 0, 0. Same, okay. 1 times 1 times 1, 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. If you can get out to that far, you're probably fine. Okay? If you went 6 times 6 times 6, you get 216. 7 times 7 times 7 is 343. 8 times 8 times 8 is 512. 9 times 9 times 9 is 729. 10 times 10 times 10 is 1,000. I'd say if you can get to this region here, just kind of knowing that, it's going to work out just fine for you. These would be just bonus things if you knew. You would have a calculator to work through those. Okay? So a perfect cube. Okay. Does anybody have a calculator with them?
Yeah.
You have one? Cool. Let's be goofy. So a little trick. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. You have a calculator, you said? Okay. I want you to take any 2-digit number from 10 to 99.
Tell you or not?
So I just wanted you to think of a number. Take the exact, so if let's say you pick, say, 25, you would go 25 times 25 times 25. Does that make sense?
Yeah.
So this is going to give me a big number. So you pick any number from 10 to 99. Okay? And go ahead and cube it. So multiply it times itself. So if you pick, 50, you'd go 50 times 50 times 50. And I need you to tell me what the big number is, not what you cubed.
Okay, I'll tell you.
Yeah, it's like 5 or a 6-digit number, yeah?
1, 6, 6, 3, 7, 5.
Okay? I'm going to split it in half. 5 goes with 5, 166, 55 squared. Anyone else have a calculator? It's on my phone, it's up front. Give me another one. 69. How do I know that? Because that's the number that everyone's going to go to.
Yeah.
I don't know what 69 cubed is, but
3, 2, 8, 5.
how much?
3, 5.
3, 5?
I mean, 3, 2, sorry.
Oh, sorry.
32, 85, 09.
32, 85, 09.
Yeah.
So I'm always going to have 3 on the right. So 9 goes there. 328 falls there. So kind of a cheap trick to do. I'll show you how to do that later. All right. So I'm on the back page 126. So that is going to be 4 raised to the 3 over 2 power. So your 3 over 2 is a little bit faded on yours, so you might want to squeeze it in there. So the bottom number, if I have a raised to the x over y, that's going to be the same thing as the y root of a raised to the x power. Okay? So if I take this, this is going to be the square root of 4 raised to the 3rd power. Okay? So friends, what is the square root of 4? What's the square root of 4? 2. So then I'm going to go 2, and I'm going to go 2 raised to the 3rd power. Well, what is 2 times 2 times 2? 8. Okay? Now, if you add your calculator, again, you could do this pretty easily. It was 4 raised to the 2/3 power. Is that what it was? Whoops. Was it 2/3 power? No, it's 3/2 power. 3 over 2. 3 over 2. 4 to the 3 over 2 power. Oops, clear. 4 raised to the 3 divided by 2. 8. Ignore the 2/3. I went the wrong way. Okay, so the calculator handles it nicely. Sometimes the calculator is going to be a good friend of yours. Sometimes it's not. Let me get rid of that notebook. Clear that, because I don't want to keep popping up. All right, so 8 to the 2/3. That is the same thing as the 3rd root of 8 squared. Friends, what is the 3rd root of 8? What times what gives me 8? 2. And I squared 2 because of this square. That gives me 4. Okay? So again, this is kind of the rule that goes with it. If you have a fraction, the denominator becomes what the radical is. The numerator of the fraction becomes, you're raising that number to a power. Now, some of you might have asked, what would happen if I went 3rd root of 8 squared, so 3rd root of 64. 3rd root of 64 is 4 times 4 times 4, so it's going to be 4 as well. So it doesn't matter what order you do it in. Sometimes it's easier to do the exponent on the number and then take the root. Sometimes it's easier to take the root of the number and then raise it to the exponent. It's going to get the exact same thing. It's the same order of operations. So as you see, this is the rule. Okay, I used a couple different letters, but do you see where the rules take place? Notice this is outside and this is inside. What's the right way to do it? Well, it depends. If you wanted to do the root of the number first and then raise the exponent, use this one. If you wanted to raise this number to the exponent and then take the root, that's the way to go about it. They mean the same thing. Okay? Good, you can see all yours. Whoa. Okay. Rewrite each expression as a radical and classify it as an integer, a rational number, an irrational number, or a non-real number. Okay, so let's write this as a radical. 24 to the 1/2 power is the same thing as square root of 24 to the 1st. Okay. Do I know the square root of 24 exactly? I know the square root of 25 is 5. I know the square root of 16 is 4. Do I know the square root of 24 exactly? No. So this is going to be an irrational number. Okay, yes, your calculator would handle it, but it's going to give you a decimal that terminates. The decimal does not terminate. It just has to end someplace. Problem number 2. This is the same thing as the square root of 16. What's the square root of 16? 4? 4 to the 1st is just 4. So that is a rational number. Okay. It's a terminating decimal. It's a whole number. It works. 2 to the 1/2 is the square root of 2 to the first. And I keep writing to the first, but 2 to the first is just 2. The square root of 2 to the first is an irrational number because you typed it in your calculator, it'll give you like 10 digits. That's where the calculator ends. And then this one, third root of 8 to the first. What's the third root of 8? 2. Rational or irrational? Rational. Okay, call it rat. Ooh. Notice I have this in parentheses. So this means the square root of -4 to the first. What number times the exact same number would give me -4? -2 times -2 is +4. It's not going to work right now, is it? Yeah, this is a non-real number. The answer to this, and you don't have to know this at this point, is actually 2i. And I is not a variable. You don't have to know the 2i at this point. Okay, but it falls into something called the non-real number system. Okay? Ooh, I have a fraction here. So this is a square root because it's the 1/2 power. So I have the square root of 4 over 25. What's the square root of 4? 2. What's the square root of 5? 5. So I get 2/5. Is 2 over 5 a fraction? It's definitely a fraction. If I can write a number as a fraction, it has to fall under the rational numbers. Okay? Huh. Little different thought. Let's see. So in your notes, you should be able to list the first couple. So I would like you to work on, I'll give you time to start it now, page 127. I would like you to do 1 through 21 all. Okay? Please note, number 20 is just this problem, 8 to the 2/3 power. Okay? If you look at number 20, it says 20.13. We added an extra 13. I don't think any of the others are goofed up. So they want you to rewrite each as a radical, like we had just done. Classify as an integer, a rational number, an irrational number, or a non-real number. So a non-real number is going to be the square root of a negative number, okay? You can have a cube root of a negative number. Evaluate the integers. So what I had just said, number 5, third root of -8, you have to realize this is the same thing as saying -2 times -2 times -2. -2 times -2 is 4 times -2 is -8. So the third root of -8 is actually -2, and that is a rational number. Okay? So that's kind of a little goof up. The backside, page 128, is blank. So you don't have to worry about doing that. So remember, friends, if you want the 4 points on the homework, try each of these. Try doesn't mean that they're necessarily right. So when I come by to check them off tomorrow, I'm going to look. Did you try each one? Oh, I didn't do it. Well, I'll say go ahead and get it done. And if you get it done after I've checked it off, that means you get a 2 out of 4. So if it's late, not due to an absence, it is worth 2 points. And I got to get the videos going for this next unit, so I don't have them posted yet, but I plan on working it next period, so hopefully we can get that done. Okay? So friends, you are welcome to get your phones, but I'd like you to work on these as well. Okay? While you get your phone, take a look at the calculator mode on your phone, okay? See how it works. Make sure when you turn it sideways, you get a lot more options.